Good day, everybody. Randy Franklin Smith here. And today we are diving into a very specific area of hybrid AD security, and that is passwords. We are going to try to convey to you everything worth knowing about passwords, password hashing and synchronization and pass-through authentication between On-Prem AD and Azure AD. So, first of all, I want to thank our sponsor, Enzoic, for making today's Real Training for Free possible. And I want to introduce Josh Horowitz, who helped me put together today's Real Training for Free. Josh, thanks to you and the folks at Enzoic. And Josh, just briefly, you want to talk about, who you are, what your background is, what you bring to the discussion today.
Yeah, sure. So Enzoic it's a cybersecurity company focused on making password authentication secure. We fundamentally do this by detecting and preventing the reuse of compromised credentials, which is obviously a major vulnerability. I'm the Chief Operating Officer here at Enzoic. We're based in Boulder, Colorado, and I'm super happy to be back in another training webinar with you, Randy. Thanks for having me.
All right. Well, here's what we're going to talk about today. First, I want to review the current state of on-prem password hashing in Active Directory. Then we'll get into how Azure AD hashes and stores your password. We will discuss Azure AD domain services. Make sure you understand what that is. That is basically the on-prem Active Directory domain technology that we know and love, but up in the cloud provided as a service for virtual machines and other applications that need LDAP and Kerberos up in the cloud. We'll talk about synchronization, both up and down, of password hashes. And we'll talk about password policy and lockout. Azure AD has its own password policy and lockout, so does On-Prem AD. How do those work together? Which one takes precedence? And let's see, we'll talk about pass-through authentication. We'll talk about password protection, both from Azure, and we'll also, while we're there, talk about the NIST guidelines, the modern guidelines for password security, and what they recommend as best practice for providing real protection for passwords today. And that is quite a sea change in our concept of what makes a password secure. So good stuff. And then we'll talk about, what is state of the art with password protection today. So lots of good stuff. First of all, we've got on-prem Active Directory. And let's talk about how passwords are hashed. Now, when the user chooses their password or when an admin resets their password, we've got our clear text password. What does Active Directory do with that? It doesn't store the clear text password unless you go to the trouble of specifically enabling some peripheral features in Active Directory, which we're going to ignore for the purposes of this discussion. So Active Directory takes your clear text password and it runs it through a number of hash algorithms for backward compatibility. The main hash algorithm that it uses is, of course, the one for Kerberos, but for backward compatibility, Active Directory may still be storing the old LAN manager password hash. It definitely stores an NT password hash and then your Kerberos one. So let's dive into that just a little more. By the way, what I have listed down here are the attribute names within Active Directory where these hashes are stored. And then after that, the attribute name where the history is stored in case you're keeping track and requiring users to select a new password and not repeat passwords. So first of all, the LAN manager password hash, that is the hash algorithm that originally gave Windows NT a bad name for security, because Windows NT, even Windows NT was backward compatible with the old LAN Manager product, and that had a woefully inadequate password hash algorithm, which I'm not going to take the time to get into now. I've definitely done a lot of webinars on it in the past, but it's largely an immaterial thing to discuss at this point because of extra security that Microsoft has band-aided onto the hash algorithm, and then also the fact that, thank goodness nowadays, you can completely disable the storage of LAN Manager password hashes, and in most cases, unless you've got some serious legacy technology that is completely outdated and unsupported, you're not going to have a problem disabling the storage of LAN Manager hashes. Now, I wish I could say that for NT. NT is a lot better. It's, by the way, it's stored in a in the attribute named Unicode, and that the Unicode PWD attribute on that user account on your on-prem Active Directory, that's basically an MD4 hash of the password. That's what NT uses. Now, you can potentially disable the network use of NT, specifically the NTLM authentication protocol. Now, of course, that's going to break anything that relies on NTLM that cannot use Kerberos. Also, there's a number of scenarios, such as if you're trying to access a remote Windows system using a local account on that system, or if you're trying to log on and access a Windows computer over the network that is not part of your trusted forest. In those cases, NTLM is the only authentication protocol that works. So as good as it would be to just disable NTLM altogether, that's still not an option even to this day for a lot of organizations, unless they stop using the scenarios where NTLM is required and upgrade applications to just use Kerberos. Finally, Windows Active Directory computes your Kerberos hashes and stores them in an attribute called supplemental credentials. And the top level or most secure Kerberos hash nowadays that Windows tries to use is this one right here, which is a combination of AES 256-bit encryption and the use of the HMAC algorithm, specificically using SHA-1 and repeating it 4,096 times. Why does Windows do that? Well, that whole idea of rehashing the password 4,096 times makes rainbow tables impractical. Just the amount of computation necessary to create the rainbow table is computationally impractical. So that's just a real quick intro to the hash algorithms that Active Directory uses. Of course, this is for on-prem technology and for virtual machines or other applications in the cloud using Kerberos. Well, of course, Kerberos is the best thing to use. And the more we can work in that direction, the better. Okay, now that's how passwords are stored in on-prem AD. Again, the actual clear text password is never stored. It's always hashed unless there is the setting store passwords using reversible encryption. In that case, the clear text password physically is not stored, but it's an encrypted form of the password is stored in AD which can then, of course, be decrypted. But that is a real weird feature that hopefully none of you have turned on in your Active Directory environment. Therefore, we can say the clear text password's never stored, just a hash of it in On-Prem AD. Now, what about Azure AD? So let's just pretend we have Office 365 without any integration to our on-prem AD. We're just completely a cloud-first and cloud-only tenant of Office 365. Well, of course, we have Azure Active Directory. That's where our user accounts are stored for getting into O365. So what happens when a user selects a new password or when an admin resets the password? Well, starting out with the clear text password, we basically send it through the NT/MD4 hash algorithm. Then Azure AD adds salt to it and then sends it through a couple other algorithms that are, there's a degree of similarity here to Kerberos. You'll see that it uses HMAC, but in between that it uses the PBKDF2 algorithm. And the other big change is instead of using SHA-1, if we go back, you see that Kerberos uses SHA-1. Azure AD uses SHA-256. Kerberos on On-Prem AD uses SHA-1 4,096 times, and then Azure AD instead uses SHA-256 I think it's 1,000 times. So at first I was like, oh wow, does that mean it's less secure? It only rehashes the password 1,000 times instead of almost 5,000 times? No, because it's using a much stronger hash algorithm in the first place, SHA-256 compared to SHA-1. Okay, so the bottom line here is Active Directory, Azure Active Directory stores a different hash, a hash that's specific to Azure AD than any of those stored in On-Prem AD. So of course that means if we're going to do hash synchronization, we have to take that into account. If we're going to have the same password supported both by a user logging onto Windows against On-Prem AD and a user logging on to Office 365 or anything else in Azure AD, then of course, you know, we have to make sure that the password's been properly hashed in all situations. So how does that work? Syncing passwords from AD up to Azure AD. And by the way, Josh, just to me, it's interesting at this point that there's not really a cloud-first Azure AD scenario supported yet. Let's say you want to make Azure AD your main repository, your main directory, and then just synchronize accounts down to your on-prem AD. That's not supported yet. And then I guess that makes sense because any company that already has Azure, has on-prem AD, has already been around, and you know, they would probably want to start out from that point in the first place. But the bottom line is, for those user accounts that are going to exist in both Azure AD and on-prem AD, that master user account, the master copy of it, is in your on-prem AD, and therefore the primary direction, the primary flow of data, at least synchronization data, is up, is going north from your on-prem AD, as you can see right here, up to Azure AD in the cloud. So what we're saying here is we have a user account named John Smith in the on-prem AD. If that user account falls within the selection criteria for the accounts that are going to be synchronized up to the cloud, then Azure AD creates a synchronized replica, if you will, of John Smith up in Azure AD. And let's talk about how the password synchronization works. A lot of the properties are just copied up there. Your username, your description, contact information, email address, stuff like that. But let's talk about the hashing. So here's what happens. You've got to install Azure AD Connect on at least one computer in your domain. And then it's going to read the Unicode password property of that user account, and that is the NT password hash. Then it's going to perform the rest of the Azure AD password hash algorithm on it. That is including the SALT, the application of the PBKDF2 algorithm, then using the HMAC algorithm, specificically SHA-256, 1,000 times. And once it's gone through all that, now it has produced exactly the same password hash that you would get for that clear text password had the user entered it in at the password resets page up in Azure. And then it sends that up to Azure AD, and that's stored with your user account up there in Azure AD. Now, what does that mean at this point? It means that you can log on to your AD domain, such as logging on to a Windows computer that's a member of that domain. And you could also just open up a browser from anywhere, potentially, and log on to Office 365, Outlook, or whatever, SharePoint and so on, Teams, or with your phone. Enter in your password and log on to Office 365 using the same password. As far as the end user is concerned, it's all authenticating against the same place, his John Smith account. He doesn't really have the knowledge that there's a John Smith account on On-Prem AD on your domain controller and also up in the cloud. Neil asks, is the Unicode password plain text or MD4? So like we said, Neil, your plain text, clear text password is never stored in Active Directory. It's the MD4 hash of the Unicode password. Why does it say Unicode? It's a long story. It all goes back to the weird way that LAN manager hashes were originally were stored. Let's see here. Yeah, so that's what Azure AD Connect does. Whenever you change your password, Azure AD Connect very quickly sees that password change within about 2 minutes at the max and sends that up to Azure AD. So there's a very short time period where potentially you could change your password in Active Directory on-prem, and then I guess if you immediately tried to go and log on to Office 365 with that password, maybe it wouldn't work for a very short time period. But that gets up there to Azure AD faster than other changes to your user account. Like if you change your description, I think that can be something like, well, it all depends on AD replication, but it can take significantly longer. Password hashes, though, sync up there very quickly. Now, let's talk about Azure AD Domain Services. So I'm not crazy about this name, but let's just be clear. We have 3 different products here. We have your on-prem Active Directory, so that's AD. Then you have Azure AD, which is just the directory in the cloud. I kind of wish they didn't even have the word Azure Active Directory on it. I wish they just called it like Azure Directory. That would actually make a lot more sense, Josh. I don't know about you, but there really isn't anything about Active Directory in Azure Active Directory. It is just the Azure Directory where user accounts and groups are stored. I think just for branding purposes, they made it Azure AD. Now, here's the thing, though. With Azure AD, you can't just spin up a virtual machine and get group policy and get Kerberos and NTLM authentication. If you want to have virtual machines in the cloud working the way they do on-prem and being able to authenticate to each other with multi-tier or distributed systems, then they have to authenticate somehow, right? And if you don't want to be going back to the old days and creating local accounts on each one of those virtual machines, and if you want to have group policy to centrally manage them, then you either had to set up your own domain controllers in the cloud or make those virtual machines members of your on-prem AD and then use a VPN or express route to handle that LDAP, Kerberos, and group policy traffic back and forth. Or now you have this product from Microsoft called Azure AD Domain Services. And so this is a managed Windows domain that gets all of its accounts from Azure AD. And it's invisible. You don't see the domain controllers. You just turn on the feature, and then when you set up a virtual machine, you say, hey, this virtual machine is going to be a member of my Azure AD Domain Services for this Azure AD directory. Now that Windows machine thinks it's in a normal Windows domain, and it uses Kerberos. When you log on to that virtual machine, it uses Kerberos against what it sees to be the domain controller, and it can do DNS, it can do LDAP, and it gets its group policy and so on from Azure. Okay, that being said, if you use Azure AD Domain Services, then we also, and if you want to log on to those virtual machines up in Azure AD Domain Services domain, then we need, using accounts from your on-prem Azure Active Directory, then obviously we are going to have to include that in our password synchronization. And so Azure AD Connect takes that into account. If you're doing password synchronization and if you have Azure AD Domain Services, then you can enable synchronization of your NT password hash and your Kerberos password hash up there to Azure AD Domain Services. Now, here's how that works for what it's worth. Azure AD Connect, in addition to doing this processing, where it takes your NT password hash and sends it through the rest of the Azure AD hash algorithm, it's also going to do this. It's also going to pull the Unicode NT password and the Kerberos credentials, Kerberos hashes out of supplemental credentials, and it's going to, here, let me get back there. This is the slide I want to be on. It's going to encrypt that with a account-specific AES encryption key, and then it's going to take the encrypted hashes and the AES encryption key, and then it's going to encrypt those with the public key for your particular instance of Azure AD Domain Services, and then it's going to post that up to Azure AD. Azure AD is going to store that on that user account, and then it's going to post that to Azure AD Domain Services where that decryption will take place, and the exact same Unicode password, NT password, and Kerberos hashes will be stored in the exact same places in Azure AD Domain Services. One extra little thing, you can disable NTLM synchronization if you want. So let's say for all your virtual machines and applications up in the cloud running on virtual machines, up in Azure AD Domain Services. Let's say you deploy that from the beginning to support Kerberos in all scenarios and situations, and you have no need of NTLM. In that case, you can prevent Azure AD Connect from sending your NT password hash up there at all. Instead, what it does is it just generates a high entropy hash that is never going to be used, but it's just a place filler, and sends that up there. The benefit being that your on-prem password hash is never leaves your on-prem Azure AD network at all. And so then if somebody broke into a virtual machine up there and somehow succeeded in getting your NT hash, it's going to be useless for anything down there on your on-prem network. Let's see here. Richard says, is Azure AD Domain Services joined to the on-prem AD? No, there's no trust relationship or any other, there's no trust, and there's certainly no forest membership between your Azure AD domain and your Azure AD Domain Services domain and any of your domains or forests down on your on-prem network. This is strictly synchronization. Thanks, Richard. And let's see here. So the bottom line then is you can have the same password across everything that John Smith needs to access in the whole hybrid estate of your Microsoft products, whether it's on-prem or a cloud app that uses Azure AD or a virtual machine that uses Azure AD Domain Services. Now, what about syncing passwords in the opposite direction? Let's say that you want to support users being able to change their password up in Office 365, or you want an admin to be able to reset somebody's password by just logging on to Azure AD, not having to be present or be able to access your on-prem AD at all. How does that work? Okay, that is supported through write-back. So in this case, we have to enable write-back with Azure AD Connect. And now, up here, either when the end user or an admin changes or resets a password, so we've got that clear text password, here's what Azure AD does. It encrypts it, and I haven't been real specific about the encryption here because this is an area where the documentation is kind of confusing and unclear. For sure, one layer of the encryption includes a public-private key pair that corresponds to the particular Azure AD Connect instance that's run that processes the password change. So key point here, you can and you want to have multiple instances of Azure AD Connect running, especially if you are using write-back and or pass-through, which we've not discussed yet. So multiple instances of Azure AD Connect is going to give you redundancy and availability. Now, if you're not using pass-through and you're not using write-back, then it's arguable that you can get by with just one instance of Azure AD Connect. If it goes down, everyone's still going to be able to log on with their old password. It's changes that are not going to synchronize up to Azure AD. Okay, But if we're using write back, then it becomes a lot more important, because if Azure AD Connect is down at the moment, here's the thing, if Azure AD Connect, there's only one instance, and it's down at the moment that the user tries to change their password, then they're going to get a message saying, hey, you just can't do it right now. Okay, so that's you might see now one of the key takeaways here of how write back works. It's synchronous, it happens live. So the user changes their password or the admin enters a new password, right then in real time, Azure AD posts onto the service bus that Azure AD Connect is watching a request to change that password. And what's sent down is an encrypted copy of the actual password. So Azure AD Connect gets that, it decrypts it. At this point, Azure AD Connect has a copy of the actual clear text password that the user probably entered a few milliseconds ago, and then it contacts the domain controller using just normal standard AD APIs for password change or password reset. And then the domain controller, key point here, is going to use whatever on-prem password policies are in place and any custom password notification packages that you have installed. And you'll see why this is important as we go along, and especially as Josh takes over. And
Randy, I think
go ahead, Josh.
I think you pretty much said this, but I just want to emphasize the two benefits or the reasons why you'd want to enable the write back. One is if you don't, then the password that has been changed and set in Azure doesn't make its way back to the domain controller, so that if somebody wants to log in on the network, they technically could end up with a second different password. And then the other reason is to have consistency with the policy. Theoretically, if you're not using write back, you can end up with a different set of rules for your Azure passwords versus your on-prem policy. So it basically allows you to have a single policy, which is usually considered beneficial.
Absolutely. And just like Whitney asks, what if a third-party password filter is in use on the on-prem AD? Yeah, that is enforced, Whitney. That's the whole point, right, Josh?
Yeah, that's absolutely correct.
So yeah, in real time, the user, wherever they are in the cloud, clear text password gets encrypted. Azure AD Connect gets that. And Azure AD Connect is running on some system in your on-prem network, no doubt, and has direct network access to your domain controller. It sends that password through the domain controller just like, here's the thing, it processes that password change just like any scenario that you would normally be following, whether it's an admin or a user changing their password, on a legacy Windows NT system, legacy Windows Active Directory integrated system on-prem. And so therefore we get to enforce everything that we're accustomed to, not just on-prem, but that's then enforced in the cloud. So if you fail your on-prem password policy, or if you're saying the user cannot use their last 10 passwords, or the password must be this long, or whatever, all of that is enforced, and if it fails, that messaging is sent back up the opposite direction, and the user gets feedback. Okay. So write back is a good thing because it allows users to maintain their password. It allows admins to reset passwords without having any direct connection to on-prem AD. Okay, now we're starting to get questions about pass-through authentication and how is this different than password sync? They are separate. So you can, technically, you can have pass-through authentication without password synchronization. So let's talk about pass-through authentication, and then talk about why you still want password synchronization. All right, so with pass-through authentication, we still need Azure AD Connect. We still need Azure AD Connect. That is the middleware that supports pass-through and synchronization. That is the middleware that gives you hybrid AD, basically, Azure AD Connect. So a user says, okay, I want to log on to Office 365. They enter in their password. Azure AD takes that password and encrypts it pretty much the same way that it does for write-back in terms of the encryption. And it posts it very much the same way through a service bus back to Azure AD Connect. By the way, it's a very efficient network communication. There's no polling involved, for instance, and that sort of thing. Very efficient, non-blocking, non-polling. So Azure AD Connect gets that, and then it uses standard logon APIs in order to find out if that user's password is good. And again, if you have custom policies installed there, that will get, the password will be run through those policies and plugins if you have any installed on the domain controller. And this is another very useful benefit potentially if you're using technology like what Josh and Enzoic provides. And so what you're going to see is pass-through authentication has a number of important security advantages. And let's talk about those. Why would you want to use it? Oh, okay. Oh, by the way, so the whole point here I think is really important to make then is what happens if you only have one copy of Azure AD Connect running and it goes down? Or, by the way, folks, remember, you could have 3 instances of Azure AD Connect running, but if they all use the same connection to the internet and that your internet gateway goes down, it's the same story. Users now can suddenly not log on to Office 365 or anything else that is authenticated via Azure AD. Now that's kind of a crazy problem to have, right? Here we have a highly available cloud, and the user is still there, their endpoint is still there, the cloud is still there, the internet is still there, but your Azure AD Connect link is down, and now users can't access anything in the cloud. That's definitely a problem. The solution is 2-part. One, run multiple instances of Azure AD Connect and hopefully use different domain controllers and different connections to the internet, different ISPs. But let's say all of those go down. Let's say they're all at one data center and you can't split them up to different sites and there's a disaster. Well, again, you could still go down. The good news is if you have synchronization, password synchronization enabled also, in addition to pass-through with Azure AD Connect, you can go in and manually flip a switch that says, okay, stop using pass-through and use the synchronized Azure AD password hashes that have been previously written to Azure AD. And users are back in business at least for accessing stuff in the cloud. So if you still need password synchronization, then why even use pass-through? At one time, Josh, people thought, oh, pass-through is good because I don't want my password hashes going up to Azure AD with the assumption that somehow Azure AD would be less secure than your password hashes already in your on-prem AD. That's not really the purpose of pass-through authentication. The benefit of pass-through authentication is it makes your cloud login subject to password expiration, to your password history, to your lockout status, and to whether the account is disabled. Now, some of these will still synchronize up, like a user account being disabled will synchronize up from your on-prem AD up to Azure AD Connect, but it won't synchronize quickly. So you could go into, here's the thing, without pass-through authentication, your admin goes into John's account and disables him in your on-prem AD. It could be half an hour, it could potentially be hours before that takes effect up in Azure AD. So that means the user, John, could keep logging on, even though he's perhaps been fired, could keep logging on to Office 365 or Dynamics or anything else that's authenticated by Azure AD for a good chunk of time, depending upon replication and Azure AD Connect and so on. Whereas if you use pass-through authentication, every single logon to Office 365, every time the user is re-authenticated, that's going live down in ultimately to the domain controller. And so really the very same code on the domain controller that handles a logon on-prem is being executed with the very same results as you would get when you log on to the cloud. And that's why you have advantages with using pass-through authentication in addition to this whole custom policy thing, which is a pretty big deal when you see the cool stuff that Josh can do. So let's just talk briefly about password policy and lockout. It's important to understand that you have a password policy on-prem and a lockout status and an account state on-prem, just like you do up in Azure AD. And which one takes precedence over the other depends on synchronization, and it depends on if you have write-back enabled and pass-through. And it's a little bit beyond the scope of today's webinar to understand all of the interplay there. But the bottom line is, it's safe to say if you have password synchronization and pass-through turned on, then everything basically comes down to what is your on-prem password policy, lockout state, and account state in terms of whether the account itself is disabled. Now, let's talk about password security, and let's get beyond traditional password policy. You know, Azure AD has been around for a long time, and our understanding of password security is in a process, is in a state of maturing right now. The NIST and other organizations that have really put some scientific study into the real world aspects of password security have discovered and have come to the point where they admit that a lot of our cherished so-called best practices about password security are not best practice really, and can actually be counterproductive. And we've talked about this in depth before in the in coverage of the special publication 863B in previous webinars. But let's just talk about a couple of them. So here's the document we're talking about. Here's a link if you want it. But some of the key takeaways are, sure, your password should be at least 8 characters, but yeah, let's not impose composition rules. Let's not say there has to be a capital letter and a symbol and a number. And let's not make users change their password every 30 days or every 90 days or even every 6 months. Let's not require the user to change their password at all unless compromise is suspected or known for sure. And here is one of the key ways to do that. We need to compare passwords against commonly used passwords or passwords that have been discovered out there on the dark web. Because one of the things that NIST really takes into account Josh, is the fact that we know humans reuse passwords at different places. You know, they will use the same password for their Gmail account as what they use for their corporate account at your company. And we cannot prevent that. We can write policies against it, but we don't know when it happens unless, and you want to talk about that just real briefly, Josh?
Yeah, sure. I mean, as you said, there's been extensive research on this, and I'm sure that nobody takes it lightly to say that the password policy recommendations that we've been living by for the last 20 years or so needed to be adjusted. But what that research showed was that those old school policies were truly making it harder for users to remember their password, and as a result, people were following just very predictable patterns in their behaviors. And really what that meant was that hackers, knowing what those behavior patterns were, could anticipate, and so at the end of the day, those policies were making it harder for users to remember, but easier for hackers to guess. And the two key things that are shown in this slide that are changes here are the elimination of the complexity rules. And I still end up in conversations on a pretty regular basis where people say, look, why should I not be requiring them to have uppercase and symbols and numbers? How can that be a bad thing? And the answer is it basically forces people to create more complex passwords that are harder for them to remember, and as a result, the characters that they put in are just in such predictable places. Oh, they put an exclamation mark at the end, or they capitalize the first word, or they convert their O's to a 0 or E's to a 3. They just follow these patterns. You'd like to think that they're using some element of randomization, but they don't. So that's why composition rules were really dismissed as counterproductive. And then the reset, again, it's the same type of thing. Why should I not require a reset? How could that possibly be a bad thing? But the reality is when a user knows that they're going to need to change this password again in 30 days or even 90 days, they follow very predictable patterns. They will increment the password with a symbol or a number at the end, or other things that really don't make them any more secure. So the new modern password policy is one where it's necessary to check against a blacklist. And I don't know if we want to talk about it here, but that's such a fundamental shift from something that was a password policy that could be evaluated algorithmically. Is this password X number of characters? Is there a symbol in it? Those things are rules, and once those rules are passed, it's going to be passed today, tomorrow, and anytime that you check that same password. Well, we're in a different world now where you're going to be checking against a blacklist, and what was on that blacklist today or yesterday may not be on that blacklist a week or a month or 3 months from now. So it really is creating a very different model around what a password policy needs to be. And we can talk more about that when we get to my section or in other areas here, but there's some really relevant points for how this needs to actually put security in place around passwords.
Yeah, and so, Azure has taken some of this into account with a product that they call Azure AD Password Protection. Basically, it's a global banned list of passwords that they have gleaned from analyzing attacks against Office 365 and other Azure AD authenticated endpoints. And they also allow you to specify a custom list. And then it does some fuzzy matching against the banned passwords. By the way, it does also support, there's a way to plug it in to also protect on-prem password changes. But there are some really important limitations. Number one, it doesn't attempt to check passwords against the whole corpus of breached passwords that we know are out there if you monitor the dark web. It also only is enforced at the time a new password is specified. But what if that password suddenly shows up in a breach of Yahoo or something like that? Password protection doesn't address that. Also, the score calculation that it gives back to the user can be confusing and just kind of be a little, from the user's point of view, kind of unpredictable. So this is very much a rudimentary little feature for password security.
Okay.
But password security in general, if we talk about true password security today, we need, number one, that compromised password detection that extends beyond, that is applied every day, not every time the user enters their password, every time the user logs on, not just when the password is specified. You know, there's a lot of other things that can be done as well, which Josh will talk about. There's, you know, if we get sophisticated, we can detect when they are manipulating their usernames just to come up with another password. Also, there's a lot of value to scanning information about your company and determining likely passwords. If you're GM, you know, you want to include all of the model names of your cars, Josh, right, in custom password dictionaries, because we know users are going to do that sort of thing. If you're based in Seattle, you know, you want to think about sports teams and things like that. So there's a lot that you can do because we've been studying how humans select passwords, and there's a lot of predictable patterns that can be put to work. Also, just understanding common character substitutions and taking all of that into account with regard, combining that with passwords that we've discovered on the dark web is a really effective way to use the same password spray methods that the bad guys use for defense purposes. So the bottom line from my part of this is, you know, password security is complex. Aside from the hashing and the protocols, really I think the most important aspect of password security today is admitting the dynamics associated with humans. And MFA helps, but passwords still have to be secure. Modern guidance is at odds with long-held beliefs about password security, and most corporate policies have not been updated. So real protection requires understanding modern password attacks, such as spraying. We have to take into account proven, documented human behavior about passwords. And we really need to put all that together into some advanced defense techniques, especially including the dark web, that the folks at Enzoic have done. And so, Josh, I think folks will be impressed when they see how you've taken all of this and made it possible to just plug it into AD, and suddenly we get the type of protection that the NIST is talking about. So I'm going to make you the presenter and show us what you can do.
Let me get back to the beginning. So I really only have 4 quick slides, and then I'll show a demonstration of the product for those that are interested. The first just basically recaps the problem that we were talking about before. It really is a human problem, a people problem, that password reuse and predictable patterns make passwords extremely vulnerable based on the policies that we've been using. And, you know, I inevitably get the question, well, wait a second, you know, should we just all go to MFA and aren't passwords going away? And I think the simple answer to that is as long as you are still using passwords, you know, it's really a layer that you're already investing in. So human behavior being the problem, I was about to make the point that really security is about establishing multiple layers. And while you still have a password layer, not hardening it against the common attacks that occur is sort of leaving open an obvious gap. It's shown to be still the number one cause of hacking-related breaches. Yes, you can have other forms of compromise to your network, but weak passwords are absolutely remain at the core. And if you rely solely on, let's say, a token-based or a multi-factor, you're really only trading one layer for the other. So what NZOA sets out to do, and I think you'll see it's very straightforward, it's very simple, is to prevent employees from reusing compromised credentials and being able to detect when existing passwords become safe. And we built this up. We've been in business since 2016, so we've been doing it for years now. But it's still a very modern approach as opposed to sort of the older school password policies. This is what the sort of flow looks like, and we talk about two key use cases here. One is making sure that bad passwords don't get into Active Directory. So we use an object called the password filter that you may be familiar with. It's a standard method that Active Directory provides to be able to set up new policies. So when somebody goes to create a password, it's checked. In this case, it does a comparison against NZOA's complete database of compromised passwords. We use what's called a k-anonymity approach, or a partial hash. So we never pass the password or even a hash of the password into the cloud. It's done through just a few segments of the hash, and then returning back to Active Directory the full hashes that we know to be compromised, so that comparison can be done locally. But because a password that was created yesterday may show up on a blacklist a week from now, we also do a continuous monitoring process. And it's, again, this is something where the expectations around passwords have changed. Like I mentioned before, when it was an algorithmic check, it would still be a secure, algorithmically secure password at any point in the future. Now, certainly before the next forced password reset, that password has the potential of showing up as part of a new data breach. And if you're following NIST's recommendations, and Microsoft's as well, to eliminate or dramatically extend password resets for the reasons that we talked about, then this gives you the ability to do that type of continuous auditing, continuous checking. And then we automate the remediation that's associated with that. This slide just simply talks about a big piece of why folks turn to NZOA is breach passwords aren't just something you could go download today. It's a continuous process of collection. We use a comprehensive approach heavily focused on our threat research team that goes out with personas into private forums and exchanges to get access to this information. It's a big job, and this is perhaps why part of Microsoft's solution is based on just their own telemetry. They're not going out, and they talk specifically about not going out to collect compromised passwords. So we're getting this information, not just the big breaches like the Yahoos, but the small ones that happen every single day. And so our database is actually updated multiple times every single day. It would not make any sense for us to have that continuous monitoring and then not update our database for another 3 months or 6 months. And there are some services that rely on that type of more static approach. This slide is the last of the slides that I have, and then I'll show you what the product actually looks like. It describes the architecture and how we actually work in a hybrid Azure environment. But this section up the top is referring to your LSA. So when somebody goes to make a password change request, the LSA passes that information to the password filter, and then it passes that along in NZOA's password filter, passes that to a Windows service that then routes out to do that check of the partial hash, as I mentioned. And if you want to proxy that so that the call can be made through another route, you're welcome to do that. And then the same process is done through the continuous monitoring. When Azure AD is set up, the only requirement for us to work fully is that password write-back that we talked about. Hash synchronization is an option, we recommend it, but as long as that password write-back is there, you're getting the full benefits of this checking process, both when the password change is occurring, that first use case, and that continuous checking process, the second use case that I described. So that's basically how the architecture works. I'll show you quickly a walkthrough of the product so you can see what it looks like. We install on each of the domain controllers. That's how that password filter piece works. But this here that I'm showing you is a server console app. It can be really run from any domain joined workstation as long as you have domain admin privileges. And its sole purpose is to allow you to see the status of your implementation and to modify the configuration. Really, this is a set it and forget it type of model, which you'll see as we look through it. There's options including here to set a one-click button when you're configuring it to align with the NIST settings, so very simple and straightforward that way. A system health tab just shows you each of the domain controllers that it's running on, and if for some reason the heartbeat that it checks to make sure that it's able to connect to Enzoic is down because that particular domain controller is having a problem or there's some type of firewall or internet issue, we'll report to you on that. Monitoring policies allows you to set up different rules for different populations based on group or OU or container, so that you can say, here's how I want it to work for my employees, and here's how I want it to work for my privileged accounts. And those differences can either be exactly how we're doing the compromised and common password checks that I'll show you, but it can also be the remediation options. So things like what action should we take when a password is found to be compromised? That can all be defined based on the group or OU, based on these policy settings that you can set. Password changing is pretty straightforward. It's simply, should we be checking at the password change event? The general recommendation is, of course, we do have some clients that have wanted to run this in sort of a audit mode in the background, so we do support that. And you have the ability to say, should I also check when my administrators are doing a password reset on behalf of users? So we can do checking there as well. So this is the first case of checking when passwords are being created. This here is the second use case of the continuous monitoring. So when this is enabled, we'll check daily each of your passwords against the most current data breach and the most current database that we have. You have various options for automated remediation. The most common one is this: force the user to change their password on their next login, but adding a delay here. So in this case, we've added a 48-hour, they receive the notification, they know that their password is found to be on a data breach or compromise, and they have, in this case, 2 days. You can change this, obviously, but it avoids there being sort of the immediate lockout or anything like that. Other options include disabling the account or notification, and you can also have it sent to administrators. The credential monitoring tab is very similar, but also very different. It's the same type of checking that's done, but here we're looking at the username and password as a pair. So if the first tab is following NIST guidelines to make sure that the password is not showing up in data breach, here we're able to detect whether that username and password pair is showing up in a data breach. If your full credentials for your organization are showing up on the dark web, that's obviously an urgent issue, so you can set up a more stringent or more immediate remediation plan. You might want to choose to disable the account right away. Additional password policies, and these are all aligned with what NIST recommends or the research shows that are those human behaviors that you need to watch out for. So fuzzy matching is basically doing leet speak substitution, those zeros for O's and threes for E's that users might think are making their password stronger. But we will reverse those out and then look at the remaining string and see whether that's compromised. Root password detection is another form of reversing out changes. So in this case, a very common pattern is to append numbers and symbols to an otherwise unsafe password. It doesn't make it any more secure when you do that. So we'll strip out prepended and appended numbers and symbols to look at the remaining text string, and if that text string is compromised, we'll block that for you as well, or detect it for you as well. We look at things like the specific context of the user whose password is changing, so their email address, login, first name, last name, to make sure those are not part of the password. And then we'll block repeating characters. So a common behavior to get around your password length requirement is basically just come up with the password that I always like to use and then hit a favorite character a bunch of times until it passes the length requirement. We'll detect that and be able to help you prevent that way of getting around your password length requirement. And then password similarity blocking is looking to see, are there enough changes being made when I do find a password to be compromised and I ask the user to change that password, are they making substantially different passwords as a result? So here we look at the distance in terms of the number of character additions, subtractions, or transformations to make sure that the new password is substantially different than the previous. And all of those are defined by policy. So different groups can have different levels of rigor if required. I'm going to jump to the second tab first, which allows you to set up a custom dictionary. So this is where you could enter in any special words that are specific to your business. So ENZOIC is not something that is a standard dictionary word. It's definitely something that ENZOIC employees would need to be prevented from using in their password. Boulder, maybe less so, because very common locations are probably going to show up as dictionary words and are likely to be in in the general compromise word lists that are part of ENZOIC's database. But here you can choose to add as many as 5,000 words that are specific to your business. If you've enabled leet speak or the fuzzy matching, we'll do that type of reversing of character substitutions. And this is a contains type search. So any password that contains the word ENZOIC for our employees would be prevented as an unsafe password. I'll jump back to network settings. So here's where you would allow a proxy if you choose to, or set a timeout. So when the password change is occurring, if you're unable to, for any reason, connect to ENZOIC, you can have this fail open, allowing the password to be saved. But because we have the continuous checking, it's going to be picked up through that process. So in this way, we're not blocking the creation of a password if there's some moment that you're unable to reach our server. Admin notifications is just that. You can set up a string of different recipients. They'll get notifications of newly found compromised passwords and notifications of remediation. Also, you can get a summary report that shows your current population that may be in a remediation state or have a compromised password and information about the different checks that have been done by ENZOIC and how many were found to be compromised. I'll show you a little bit more about that in the reporting tab in a moment. And then we do offer a Windows client. So this is specific to the Windows machine. This is one piece that does not work with a hybrid Azure environment in the sense that Windows does not pass the full custom message back to Azure. However, on the local workstation, if you've come up with an ENZOIC policy, we can display that policy to the user, telling them that this must not be a compromised or common password. And when they go ahead and change their password, assuming I don't fat finger this, we'll let them, well, no, we'll let them know that the password that they enter is compromised. So it gives them a little bit more of an intuitive message. And this is done in real time against our full database. So there's no delays or waiting to get a notification, which is obviously important. That's the client settings that I just showed. So we can disable that if needed. And then other settings is simply the continuous checking process you can designate which server is doing that so that you can specify where that load should go. It actually happens to be an extremely lightweight process, so it's, but you can specify where. And then reporting, a few different screens that just show you the number of checks that have been made through either the password reset checks or the continuous monitoring. And when I roll over this, it'll show me, in this case, I had 6 checks. It was a fuzzy match that was found for the one that was compromised. This one has one that's a fuzzy match, one that's an exact match, and I can look to see all my users, what status they're in. All of NZOIC's logs are in a JSON format, so a lot of our clients will integrate our logs into a SIM. So if they want to have other notifications or kicking off tickets, it makes it easy to do that. So it's a pretty simple product. Its purpose is to make sure that users are not creating passwords that are found in cracking dictionaries, commonly used passwords, or otherwise compromised, and to do that both at password change and on a continuous basis thereafter. That is all I really had. We have a free license that's available on our website for up to 20 users. We also have an auditing tool that's available for free. So if you just want to run a quick scan of your environment, it's called NZOIC for Active Directory Lite. That password-auditing-tool link that's shown will get you to that, and it can give you a sense of how many passwords are known to be compromised in your environment.
So Josh, that's awesome. We got some good questions. You ready for those?
Yeah, bring them on.
So by the way, I think I've answered all the questions people sent to me. So just look in the Q&A window for my answer if you've already asked me something. But Josh,
you want me to just look through the questions and try to answer them?
Yeah, or I can facilitate them for you. However you'd like to do it. It might be easier if I just throw them your way.
Okay.
Patrick says, how do you check old passwords for vulnerabilities? So I think he's referring to when somebody's already specified their password, they've already changed it, and then Yahoo gets hacked or somebody else, and that same password they used again somewhere else shows up in a list out on the dark web. How do you catch that?
Yeah, well, that continuous process that I described is showing, and let me see if I get back to the slide with it, but basically we're doing the same partial hash comparison again and again to see whether that password has now been part of a new data breach. And that is super important if you think about the fact that we're getting rid of password resets and passwords that might have been safe yesterday may not be safe tomorrow. That's just fundamental to a modern password policy.
So I think what maybe he's asking is, are you rescanning everybody's hash and checking it against the latest list, or do you catch it at the next time they try to log on?
No, it's continuously done in the background, taking that partial hash. It doesn't check at the time that they log in. We're doing it every single day, whether they log in or not.
Okay, cool. So what percentage of customers do you see that are actually removing periodic password change requirements, maximum password age?
Yeah, that's a great question. I think it's probably 40, 50% at this point. It's a conversation, 100% of the time, and it's often there's somebody internally that's just adamant that that they don't want to get rid of password expiration. So a lot that aren't getting rid of it completely are moving to like a 365-day password reset. But if you actually look at what NIST and SANS and Microsoft itself says is, it doesn't matter because there's no amount of time. If my password policy is to force a change, there's just no amount of time that's short enough if your full credentials are floating around there. But that's what we're seeing today.
Yeah, I have to agree that the logic, well, you got to at least change it every year. So what risk are we addressing by doing that? Are we saying, well, at least if the password gets compromised, the bad guy can only use it for up to a year?
Yeah, it does raise some questions there. And, what you want, the whole point of, or one of the points of this is give people the incentive to come up with a strong password. Let them know that, it's going to be at least a year, if not, until there's something else arises that makes it insecure, that it's worth taking the time to come up with a good, healthy, long password.
Absolutely. And Mark also follows up and asks, do you recommend then that customers, if they've got a product like Enzoic in place, really that password change is truly unnecessary and perhaps even detrimental then? Is that your stand, basically?
It is, but it's not really our stand. It's NIST's stand and Microsoft's stand and the FTC's stand. And I've got, because obviously I'm in this business, a whole long list of the third parties that make the same argument. So it doesn't need to come from me. But yeah, that's the prevailing message. Whether organizations are ready to get there is another question.
So here's a question I hadn't thought of. Albert says, how does this affect password requirements in PCI?
So PCI is, to my knowledge, still requiring some things that contradict NIST. Generally, what I've read is that PCI is looking closely at NIST, and that's really sort of the way it tends to flow down from NIST to other compliance organizations. We do have some customers that have used the methods that are provided in Enzoic as a mitigating control to be able to say, look, here's why we're changing our policy and have been very successful getting that passed through auditors. But we certainly understand that there are still some password policy requirements depending on what you're held to. These are quickly changing to line up with these modern recommendations because all the research is there. But we certainly understand, your mileage may vary based on what you're held to in your industry.
Christopher has a question. I want to take a stab at it also. It says, if we filter passwords based on NIST, are we inferring the standard to the attackers, i.e., what passwords won't be? And so I understand the idea there. However, I don't believe we're making ourselves any weaker if we let attackers know that we're not going to use any password that's already been out there on the dark web. Someone else says, they seem to say, what aren't we, somebody said, what happens when every, easy password or every password that's just A through Z has been compromised? So I don't think we're anywhere close to that. I think if you took all the unique passwords that have been breached and published on the dark web and compare that to whatever the set is of quote unquote easy to remember passwords is, I don't think we're coming anywhere close to exhausting that.
Well, at 8 characters, I would say most easy to remember passwords have shown up in data breaches, and in part because 8 characters is really, even though it is a NIST standard, you sort of heard me chime in when we were playing the NIST requirement around that, longer is absolutely better. I think the simple answer to the question is if you're comfortable remembering a password that is, on the surface, as you look at it, more a random jumble, then sure, then you're certainly welcome to do that. But it guides people towards what we know to be better practices, longer passwords that have not shown up in cracking dictionaries that are that's more secure. And the encouragement is, hey, because these other constraints are lifted in terms of character complexity, come up with a few unrelated words and you're going to end up with a much stronger password than if you've tried to come up with 8 characters that may be difficult for you to remember.
Yeah, the whole 8 characters. So first of all, if we were going to really belabor this, we would have to define what is an easy to remember password.
Yeah.
And I always forget, I've been practicing passphrase for a long, long time. So, I would never consider just using a word out of a dictionary. And if that's what we're calling an easy to remember password, then, that's why we have to define what that is. But the other aspect to that is, well, actually, I think I'll cover that here in another question. Let's move on to the next question. Will this work on Mac OS? So how about that?
Yeah, I mean, to the extent that it's working, everything that I showed is working at the on the server level and for the way Active Directory functions. Then yes, it will not work with a if you're using something other than the Control-Alt-Delete password change. Specifically, I'm referring to the Windows client where it shows the custom messaging there. That custom messaging, and I think I've got let me pull up that, here's another illustration of that, where we'll show you the policy and give informative response. That's unfortunately a limitation of Windows, and there's no product that unfortunately can work to provide a custom message back that way for something for other technologies other than Windows. But we've got a high proportion of our customers, to be very honest, that aren't using this Windows client approach and have no issues. It's just, I think, a nice to have if you can support it.
Do you have and I might have missed this, do you have a self-service password change or password reset portal that gives them the same feedback?
No, we don't. Most of the customers would be using the SSPR. There are certainly, if we put everybody to our own web page, we could support that. We haven't seen a lot of demand for it, but if folks are interested in that, I'd love to hear it. That has not. This whole area has not been a major requirement for customers. It's it is something to consider. Messaging when you're changing any password policy for that matter, but it's generally been more of a nice to have.
Gotcha. Benjamin asked, what about Azure joined workstations? That would be another situation where they wouldn't get this feedback, and I don't want to keep harping on that, but he asked the question. Yeah,
sure. So Azure joined workstations. We're absolutely going to support the password change there. And the nice thing about sort of the architecture and the way we work, it's really going to support changes wherever they take place, whether it's on the SSPR, whether it's on your mobile device, whether it's on a Mac device, whether it's on through Azure and the O365 page, whether it's through Okta. That's the architecture here that it's going to support all of those different environments.
I tell you, something that, hey, this is just an idea. If folks are really hung up about the feedback thing that you don't get in some scenarios, you could still deliver that feedback to the user pretty quickly via email or Teams messaging or something like that for what it's worth.
Yeah, absolutely, it's possible. And I think, I just listed a whole bunch of the places that people need to and like to change passwords. we think it's better to allow support for all of those areas rather than force everybody through, one specific path. Because I think even shutting off all places where you could potentially change the password and is itself a major project. I don't want to underplay the feedback element, but you're absolutely right, Randy. There are different ways of doing it if for some reason your population is having questions about it. But I think the key thing is to make sure that you have a policy that reflects this modern approach.
Let's see here. We may have some trouble understanding this one. Does product cross forest into the single pane of glass? Being that it isn't, so I'm not sure what it's, maybe a question you could come back to later. You'll get a copy of all of this, Josh. Also, Mark,
are users giving us enough information? So if there's a follow-on question that will be able to. Okay, great.
Mark has a pricing question. He's like, can you clarify premium versus enterprise? It mentions a certain amount per month, but user count is custom. So maybe that's something you want to take up offline with them, unless you want to get into pricing right now.
Real briefly, there's a product that is everything that I showed you today, which would be the enterprise version or premium version. There's no sort of functional difference between those two. Enterprise tends to be for larger organizations. Say, for instance, if you provide if you need a custom SLA or a negotiated contract or things like that. The premium simply is off our website. You can enter a credit card, and we simply just charge you at the end of the month for how many Active Directory accounts that you are protecting. The business version is the same as the premium, except it doesn't include the full credential monitoring, so username and password checking. It's just checking the password. And then the second thing is the multi-policy support. So if you needed to have a different policy for privileged accounts versus your employees, that would be a requirement to push you into the premium or enterprise level. And it is on that pricing page. So we try to be very transparent there. Everything's laid out for you.
And Josh, that's another limitation of Azure password protection that one of the attendees highlighted is it's just one size fits all policy. You can't, take an administrative unit or a group of people and give them a different policy with Azure password protection.
Yep, that's true.
Marie says, if a DC sync has occurred on your Active Directory, will having Enzoic help in rectifying Active Directory? There's something missing in that question, unless you...
No, I can't interpret that.
We can come back to you, Maurice, offline. And then I think that's pretty much it. That's pretty much it as far as our time. Thank you, folks. And we got a ton of questions today, which I think is always a good thing to see. And Josh, thanks a lot for making this whole session possible and showing us your cool technology there.
Oh, it's my pleasure. It's a great training, Randy. Thank you.
All right, folks, have a great day. We'll be in touch again soon, but bye-bye for now.